Chapter 17 asked what changes when public agencies govern outcomes rather than account only for activities. Chapter 18 moves one level higher. It asks whether the regulator itself operates as a system that can learn from the field it oversees. That question matters because a regulator can demand strong controls, collect detailed reports, and still discover too late that the industry has drifted away from the assumptions inside the rulebook. The same separation between the paper system and the living system appears on both sides of the supervisory relationship. The regulated firm experiences a drift in its operations. The regulator experiences it across an entire sector. The purpose of this chapter is practical. It shows how the Digital Value Management System, or DVMS, can serve as a regulatory operating overlay. The statutes remain. The supervisory manuals remain. The examinations remain. What changes is the connective tissue that links legal intent, field evidence, regulatory decisions, and institutional learning. The diagram on this slide shows a dense regulatory structure intersected by a single visible line. That line represents the path from public intent to evidence of a real outcome. Most regulatory systems contain the individual components shown in the background. They have mandates, offices, reporting channels, examination teams, enforcement processes, and policy functions. The difficulty is that these components often operate alongside one another, rather than as a single learning system. A regulatory operating overlay does not add another bureaucracy on top of the first one. It connects work that already exists. A statutory objective becomes a testable outcome at a specific boundary. Field observations become evidence against that outcome. Evidence informs supervisory decisions. Those decisions leave a trace, and the trace later shows whether the intervention improved the system or merely created more reporting. The shift is from documentary compliance to demonstrated capability. Documentary compliance asks whether the required material was submitted. Demonstrated capability asks whether the regulated system can protect the outcome under real conditions, and whether the regulator can recognize when that capability begins to weaken. The left side of this slide presents a reassuring picture. The dashboard is complete, the score is high, and the record appears orderly. The right side shows the system failing behind that record. Both pictures can be accurate at the same time because the report and the operation are distinct objects, updated through different processes and at different speeds. The Boeing 737 MAX certification history illustrates the danger. The aircraft passed through a formal certification process, yet a congressional investigation later identified faulty technical assumptions, limited transparency, and insufficient FAA oversight. The lesson is not that certification has no value. The lesson is that a completed certification record cannot substitute for a live view of the behaviors, incentives, and technical dependencies that determine safety after the record is approved. A regulator, therefore, needs more than proof that the required activities occurred. It needs evidence that the underlying boundary still holds. Without that evidence, a regulator can be satisfied on the record while the public remains operationally exposed. Every regulator works through two systems. The paper system contains statutes, manuals, reporting templates, examination procedures, and annual dashboards. It preserves institutional memory and makes decisions repeatable. It also moves at the speed of publication, review cycles, and formal approval. The lived system moves differently. It appears in hotline calls, examiner judgment, regional patterns, near misses, workarounds, and the questions staff stop asking because experience has taught them that the answers will not change anything. These signals often appear early, but they are fragmented and difficult to aggregate. By the time they reach senior officials, they may have been cleaned into a summary that no longer carries the original warning. The risk lies in the unmeasured distance between the two systems. If the paper system says a control is effective while field staff repeatedly see the same workaround, the agency does not have two competing opinions. It has evidence of drift. The overlay makes that drift visible and routes it toward an authority that can decide what must change. The layered blocks on this slide matter. Existing frameworks, sector guidance, supervisory manuals, and legal requirements remain in place. DVMS does not compete with them because it performs a different function. Those sources describe what warrants attention. The operating overlay connects that accumulated knowledge to the evidence produced by real work. This distinction prevents a common failure. When a regulator recognizes that the current system is too documentary, the first instinct may be to issue another template or add another reporting requirement. That action enlarges the paper system without repairing the feedback loop. Firms respond by creating another submission process, while examiners inherit more material to review, and there is no better way to determine which boundary is weakening. An overlay changes the relationship among existing components. It asks where the statutory intent becomes operational, what evidence would reveal whether the outcome holds, who can act when it does not, and how that action changes future supervisory practice. Nothing valuable is discarded. The pieces begin to work as a system. This slide recasts regulation as a value stream. Statutory intent and policy direction enter on the left. Verified system resilience is the output on the right. Between them sits the regulatory engine, where the agency interprets rules, designs expectations, engages regulated entities, learns from incidents, and adjusts its practices. Seeing regulation this way changes the unit of analysis. A rule is no longer complete when it is published. Publication begins a cycle. The agency must see how the expectation is interpreted in the field, how firms implement it, what evidence emerges at critical boundaries, and whether that evidence supports the outcome the rule was written to protect. Consider operational resilience requirements in financial services. Regulators increasingly organize attention around important business services and impact tolerances rather than around isolated systems. That outside-in view starts with the service the public depends on, then traces the processes, technology, people, and suppliers that make it possible. The regulatory value stream becomes visible because the agency can follow intent all the way to an experienced outcome. The 7 capabilities on this slide are not 7 departments, and they are not a sequence that runs once. They are the minimum capabilities that the regulatory engine must continuously express. Govern translates statutory purpose into outcomes that can guide decisions. Plan directs limited attention and resources toward the boundaries with the greatest consequence. Design converts intent into usable supervisory patterns. Execute performs the daily work of reviews, examinations, engagement, and enforcement. Assure tests whether that work produces the intended outcome. Change updates rules, guidance, and operating practices when evidence reveals a gap. Innovate pilots a different method before crisis conditions force improvisation. The capability view also reveals why adding more examination effort may not solve a regulatory problem. If execute is strong but assure is weak, the agency can complete more reviews without learning whether those reviews improve resilience. If assure identifies recurring drift but change cannot update policy or practice, evidence accumulates without consequence. The system works only when all 7 capabilities connect around the same outcome. The upper line on this slide shows a healthy regulatory thread. Each activity produces something that the next activity uses. The lower line shows a familiar failure. Reports continue to arrive, teams continue to work, and the thread still looks complete on an organizational chart. In practice, one handoff no longer carries meaning. 3 questions expose the break. First, what outcome did govern establish at this boundary? Second, what evidence does assure collect against that outcome? Third, when the evidence drifts, how does change alter what the agency expects or does next? A vague answer to any one of these questions identifies a broken connection. Hotline data offers a simple example. Collecting thousands of complaints is an execute activity. Sorting those complaints into categories is still not assurance. Assurance begins when the agency tests whether the pattern signals deterioration at a specific boundary. The loop closes only when that finding changes examination priorities, guidance, enforcement, or the design of the reporting process itself. Otherwise, the agency has a well-maintained archive rather than a learning thread. Protecting the integrity of the financial system is a legitimate statutory purpose. It is also too abstract to examine directly. The funnel on this slide shows the move from that broad purpose to a payment settlement boundary where integrity becomes observable. At that boundary, the regulator can ask whether obligations are settled on time, whether a supplier failure can be contained, whether transactions can be rerouted, and whether a backlog can be cleared without creating unacceptable exceptions. Those questions preserve the original mandate. They also give examiners something concrete to observe and regulated entities something concrete to demonstrate. The abstraction trap appears when an agency remains at the level of broad language and compensates with more documentation. The resulting reports may describe governance, resilience, and risk in polished terms without showing where the public would first feel a failure. A boundary corrects that problem. It identifies the point where an abstract promise becomes a real service, a measurable obligation, or a visible public consequence. Once the boundary is clear, the question outcome and question metric structure determines what evidence matters. The question outcome asks what must be true here to protect the public. The question metric asks for the smallest useful set of observations and tests that can show whether the outcome is real. The surrounding frameworks on this slide still contribute. The NIST Cybersecurity Framework, regional rules, and sector guidance help identify relevant concerns and establish shared language. They do not, by themselves, prove that the payment settlement boundary can withstand a supplier failure. The QOQM structure connects those concerns to operational evidence. This changes the supervisory request. Instead of asking only for a policy, the examiner can ask for failover test results, recovery performance, exception patterns, and evidence that prior drift changed the operating design. The request becomes narrower and more demanding at the same time. It requires less generic material and more proof that the outcome holds under the conditions that matter. The root outcome in this example is direct. Settlement obligations are met on time, even when a critical supplier fails. The statement identifies the service, the performance expectation, and the stress condition. It is specific enough to test and broad enough to preserve the public purpose behind the regulation. The first branch examines rerouting. Useful measures include tested failover time, the success rate across realistic drills, and the error rate after cutover. The second branch examines backlog management. Measures include backlog size during degraded operation, the time required to clear it, and the exception rate during recovery. These measures reveal the difference between intent and capability. A firm can own a detailed continuity policy and still discover that routing takes twice as long as assumed, or that recovery creates an unacceptable error rate. The regulator does not need to prescribe every technical design choice. It needs credible evidence that the chosen design protects the outcome. That preserves firm ownership while giving supervision a defensible basis for challenge. Regulated firms often produce similar evidence several times for different audiences. Operations needs one view, risk needs another, internal audit asks for a third, and the regulator requests a fourth. Each version consumes effort and introduces another chance for the story to drift away from the underlying data. The slide shows a different model. One maintained QOQM trace can serve several purposes because every audience follows the same line from outcome to evidence to decision. Govern uses the trace to confirm that intent is being measured. Plan uses it to direct resources toward observed weakness. Change uses it to justify an update to a manual, examination pattern, or regulatory expectation. Portable evidence does not mean unrestricted data sharing or one universal report. It means preserving the meaning and provenance of the evidence as it moves. The receiving audience can see where the observation came from, which outcome it supports, what decision followed, and whether the decision worked. That reduces the reporting burden because the agency asks for evidence that the system already uses to manage itself. After a visible failure, the public asks 3 questions. Did the responsible institutions understand the risk? Did they act once the risk became visible? Will the same conditions produce the same failure again? A regulator loses trust when it can answer only by citing procedures followed and documents received. A working overlay gives each question an evidence path. Defined outcomes and boundaries show what the agency understood before the event. Execute and assure records show what the agency and the regulated entity did as the evidence changed. The change capability shows whether learning altered the paper system, the supervisory pattern, or the operating design. This does not promise that failure disappears. Public trust does not require a claim of perfect prediction. It requires a credible account of attention, action, and learning. The strongest account exists before the press conference because the decision trail was produced by the operating system itself, not assembled afterward to defend an institution under pressure. A learning regulator connects legal intent, institutional capability, field evidence, and learning into a single continuous loop. The loop does not wait for a scandal. It searches for drift while the consequences remain small enough to manage deliberately. The FDA's Sentinel initiative provides a useful real-world illustration of this direction. It complements traditional reporting by enabling the agency to query large, distributed healthcare data sources to address emerging medical product safety questions. The existing surveillance tools remain, but active field evidence strengthens regulatory decisions. That is the logic of an overlay. Preserve the established system, then add the feedback capability needed to quickly see what the established system cannot see on its own. The final principle is simple. Regulation becomes resilient when it can learn at the speed of the system it governs. Statutes provide intent. Capabilities organize the work. Boundaries make the intent observable. Evidence reveals drift. Decisions close the loop. When those elements remain connected, the regulator does not discover every weakness through a headline. It can identify and quietly close many of them while there is still time to choose a response.